Okay, October 4th, 2011, we're on lesson 2.2, factoring quadratic expressions. We're going to go over factoring polynomials, and then we're going to get into quadratic expressions. So, an example of that would be if we had the expression f at x is equal to 2x minus 6. Okay? If we were to factor this, we're going to be looking for the greatest common factor of both terms. Assume it's the coefficient of the term. So we're talking about the 2 and the 6. I could write the factors out on the side if I wanted. I could write down my factors of 6, 12, 18. I'm going to do factors of 2, 2, 4, 6. Oh, what am I doing? Those are multiples. Whoops. Good
job, sir.
Sorry. I'm like, that doesn't work. When I'm talking about factors, sorry, I mean like a factor tree. Have you guys ever done prime factors? We could write out the prime factors, which are 2 and 1, and factors of 6 will be 2 and 3. So the common factor here is the number 2. I can take the number 2 out of both terms. What I mean by that is I'll divide both of these terms by the number 2, and that 2 comes to the outside. We encompass the two terms in brackets, and that 2 comes to the outside of the brackets. 2x divided by 2 is x, and let's do a division sign.
Sir, we were taught with square brackets.
That's fine. Negative 6 divided by 2 is negative 3. So the factored form of this is f at x is equal to 2x minus 3. So our second example. Our second example, we need to find the greatest common factors again of these terms. Okay? So if you guys take a look at this, I can break these into prime factors again. Some of you might be able to notice right away that this is, I can take 2x out of both of these. I can divide both by 2x. I end up with 2x on the outside. Whatever I divide by, I bring to the outside. 2x divided by, 2x times bracket 3x minus 5. Okay? Now, if you're not quite sure how we got to that step, another way you could do this is to break these into prime factors. So, 6x squared. I'm going to break the 6 into its prime factors, and I'm going to break x into prime factors. So, 6 can be broken into 2 times 3. X squared can be broken into x times x. Okay? So, I can break that into all of those different numbers, so I end up with technically 2, 3, x, subtract. And all I've done is broken this number into all of its prime factors. And then I can break 10x into its prime factors. No. 10 can be broken into 2 and 5. Both are prime numbers. And x can't be broken down anymore. It's just x. So our prime factors of 10x are 2 times 5 times x. Now what you can do to solve this now is you take out common numbers. So if I look, there's a 2 in both of these. So I'm going to be taking that to the outside. And there's an x in both of these. So I'm going to be taking that to the outside. I'm going to move this down. Let's try that again. There you go. So what that means, I take the ones I've circled in red, I take them to the outside. 2x. So again, we've taken 2x to the outside. And then whatever's left over, we put inside the bracket. So I have 3x. I have the subtraction sign. And I have the number 5. They're the only things that weren't circled. I end up with my answer 2x times brackets 3x minus 5. Now, if you can do this without breaking it into prime factors, that's completely fine. It's just the greatest common factor we're looking for. We're going to use a different question. I'm going to use a different way to solve this. There's many different ways we could use. What I'm going to do is I'm going to take the factors of our coefficients. So, 27. I'm going to write the factors of 27, which are 1 and 27, 3 and 9, and that's it. Then I'm going to write the factors of 9, which are 1, 3, and 9. Okay? I'm going to look for the greatest common factor after I've written all my factors out. So I look through them. 9 occurs in both. So I know I'm going to be dividing both of these terms by at least the number 9. The next thing I look for are the factors of x squared and x. Well, factors of x are just x, and factors of x squared are just x times x. Okay? So what I'm going to be doing is I'm going to be taking out, again, I don't have to repeat x times x. It's just x. Okay? I'm going to be taking out x to the power of 1. Another way to look at it is whatever variable has the lowest exponent. So this one's to the exponent 1. This one's to, sorry, that's to the exponent 2. This is to the exponent 1. We'll divide by the variable with the lowest exponent. So because the lowest one was x to the power of 1, I'm also going to divide all of these by x. Now, whatever I divide by, technically that's the number I put outside the brackets. So my 9x comes outside of the brackets. And I divide these. 27x squared divided by 9x, that's going to give me 3x. And negative 9x divided by 9x is just 1. So the factored form would be 9x times 3x minus 1. Minus 1. All right. Say we are... Oh. Okay. So again, we have to find the greatest common factor. Because the coefficients are all the number 1, clearly we divide by the number 1. We know we're going to be doing that. That's not going to change anything. But what is important is I look at all of our variables and their exponents. The lowest exponent is a variable x to the power of 2. So I'm going to divide by x to the power of 2. Whatever variable has the lowest exponent. So we're going to divide all of these terms by x to the power of 2. In our next line, that's the number that comes outside, the number 1, x to the power of 2. And the 1's not important. We technically don't have to write it. And now I just bring down what the divided terms are. So x to the power of 4 divided by x to the power of 2 is x squared. X to the 3 divided by x to the power of 2 is
x 1.5.
And this one becomes the number 1. So we get x squared times bracket x squared plus x minus 1. Okay. In this example, again, we're looking for a common factor. Now this one looks different. It looks like we have 3x multiplied by this bracket, 2 multiplied by this bracket. What I want you guys to realize is the two brackets are the exact same number, so they become the factor. We're going to take the bracket and take it to the outside. Imagine like this is all encompassed by in one big bracket, okay? We're going to take those two brackets to the outside, x plus 1, and it's just that. And then inside the old bracket, like we did before, whatever numbers or terms left over, we're going to leave them. So we have 3x, so I leave 3x, and I have negative 2. Negative 2. So I know I got some funny looking brackets now. I'm going to replace them with normal ones. So essentially this question ends up becoming x plus 1 times 3x minus 2. Again, all I did was I took the two brackets that had the same numbers, we took it to the outside, and whatever terms were left over, we put in a new bracket. Imagine this, just like we've done the other questions, and what we've really done is divided the first two terms by x plus 1 and x plus 1. So we've divided the first two terms by that. I remember before, whatever we divide by, we bring to the outside. When we divide, these will cancel each other out, and all we'll be left with is 3x minus 2. So we put those terms in the second bracket. So what we divided by, we brought to the outside, and the two terms that are left go into the second bracket. So we're going to end up with two brackets, x plus 1 times bracket 3x minus 2.